Hello, my name is Craig White, and I'm going to be talking to you about energy, the built environment, and the climate emergency. Unfortunately, we live in a time of multiple crises. We have the climate emergency, we have a housing crisis, and we also have the pandemic. And just 2 years ago, had any of us heard of Greta Thunberg? And now Extinction Rebellion take action about climate emergency and change the ways our cities work. And of course, at the very smallest scale, the COVID-19 virus has touched us all in some shape or form. But let's move out a bit. Some of you will have heard of One Planet Living. It's the means by which we measure our environmental footprint. And it goes like this. If every man, woman, and child on the planet were given an equal amount of land, we would all have 1.9 hectares. And if all 7 billion of us lived like Europeans, we would need 3 planets worth of resource, or 6 hectares each. We can make ourselves feel a little bit better by looking at America, and the average individual American requires 12 hectares of land to maintain their lifestyle, or 6 planets worth of resource. And the question we need to ask ourselves is, does an American have twice the lifestyle quality of a European? And the answer is no, they don't. What we have is disproportionate resource use. So we need to change the way we think about the amount of resources we use, and energy is one of those. But let's zoom out even further. This is our sun, and for the moment provides us with all the energy we use on the planet. Whether that's through fossilized solar energy that was gathered by plants and animals 100 million years ago, or whether that's through photovoltaic cells on our rooftops that gather energy from the sun today. And it's a big system. It drives almost everything we understand about how the planet works. It drives our weather system. This is a solar-powered system. As the Earth spins and hot air rises, it causes vortexes in our atmosphere. It causes our weather patterns. And we're clever enough to capture that energy through wind turbines. So wind is a solar energy. And that wind blows across our oceans and causes wave energy, another form of solar energy. And of course, it powers every living thing on the planet, whether they be plants or animal. We are all powered by solar energy. And this energy system uses a currency in 2 forms. The carbon atom, and when combined with 2 oxygen atoms, carbon dioxide. And it is the change between the two where we release energy that powers our world. But there's an issue when we release too much CO2 into our atmosphere. It's very good at insulating, and it can cause our atmosphere to retain too much heat. But how do we know this? Well, this is a chart of the Vostok ice cores, and the top one shows us how much CO2 was in the planet's atmosphere over the last 450,000 years. The bottom chart also shows the temperature on our planet, and we can see high levels of CO2, we see high temperatures, and we see low levels of CO2, we see lower temperatures. And what we're looking at is the last 4 ice ages and the stages in between, which were warmer. So nature works with carbon dioxide, moving it in and out of our atmosphere quite naturally. So what's the problem? Well, the red arrow points at the level of CO2 today, and this has been produced by us. If we zoom in a bit more, we can see the data for the last 2,000 years, and towards the right we can see the invention of the steam engine. Then a little later we invented the oil derrick, which allowed us to extract oil out at much faster rates than we were able to extract coal, and then we see the red spike. So our demand for energy has released more CO2 into the atmosphere than nature has ever done. And when you add too much heat into our atmosphere, we get unwanted effects. This is Katrina, the hurricane that hit New Orleans. This is Sandy, the hurricane that hit New York. And pretty recently, we have seen 3 hurricanes in the Atlantic. Florence, Isaac, and Helene all exist at the same time. So too much CO2 in our atmosphere changes our weather patterns. And too much heat held in our atmosphere causes the surface temperatures to increase. But it doesn't do it evenly. In fact, our polar caps are heating faster than the rest of the world. The risk is we will melt our ice caps and cause sea level rise. So we need to deal with things differently as we go forward. And sustainability is the definition we use to have us think harder about the impacts we have on the planet. And if we do this correctly, we call it the triple bottom line of sustainability, where we look at 3 things: the social, the economic, and environmental impacts, and try and bring them into balance. I would also add a 4th, the cultural, because unless we understand how we each think about these things, some of us might preference the economic over the social, or the environmental over the economic. We all approach this in different ways. But what is certain, we need to have them in balance. And this brings us to something called systems thinking, which some of you may have heard of. And systems thinking recognizes that we all live in an interconnected and interdependent world, where sustainability, quality of life, our health, well-being and happiness, and our productivity all have to coexist. It's complex and it gets messy, and energy is part of this. We're also extremely wasteful when it comes to resources. And my view is there is no such thing as waste. There are simply resources in the wrong place at the wrong time and valued incorrectly. Nature doesn't create waste, so why do we? Nature constantly cycles resources, and this circular approach has led many to think about a new circular economy, where we emulate how nature works and bring things back into a better balance. So when we add it all up, it can get quite depressing. Do we have an existential threat? Is this leading us to have stress, anxiety, and depression? The need for well-being is now scaled across planetary, societal, physical, and mental. It's a huge span, but we can think quite differently about this. And the phrase is to think global and act local and act now. So let's look at the construction industry and energy. Well, it's a very valuable business, being in construction. Globally, it has a value of £2.9 trillion per annum, but it's also responsible for 44% of all man-made CO2. And buildings impact on the environment in 3 ways: through the resources we use to make them, through the energy we use to operate them, and through the waste produced in their construction, operation and disposal. They are also the places where we live and work, and they impact on our social, physical, and economic and cultural well-being. And some more facts. 60% of all materials on the planet by weight are used in construction. 12% of all CO2 emissions are embodied into the materials we use in construction. And the dirty little secret that nobody likes to talk about is that 20% of all materials by weight end up in landfill. So buildings impact, and our job is to minimize that. And we have lots of good guidance from around the world to have us think differently about how we go about doing this. These are the 17 Sustainable Development Goals from the United Nations, and they ask us to ask questions about poverty, about hunger, well-being, education, equality, all the way through to peace, justice, and partnerships for how these goals can work. And our built environment and the energy it uses is a big part of how we can improve our environmental objectives. And energy use in buildings is also a strategic problem for us. This is a chart that shows our gas use from 2004 to today. In 2004, we were entirely self-sufficient in gas from our North Sea reserves. But today, we have to import 80% of all the gas we consume to drive our heating and power systems in the UK. So where do we get our gas from? Well, 40% comes from Russia, and we might not be certain about a consistent supply from Mr. Putin. Another 40% will come from the Middle East, where some of our recent activities might also mean supply might not be consistent. So our national gas flame is at risk, and we need to be able to find other means of powering our UK economy. And there's also a lot of legislation that drives us to think differently about energy. The EU targets, and they're still ours for the moment, mean that we all have to reduce CO2 emissions by 20% by 2020. We also agreed that if the rest of Europe did exactly the same thing, we would reduce it by 30%. And we actually achieved 29%. The target was also to produce 20% of all energy using renewable technologies. And I'm really pleased to say that in 2019, we actually achieved 37%. We have also enacted something called the Climate Change Bill, and we're the only country in the world to have enshrined into our laws our commitments to reduce CO2 emissions. And that's something to be proud of. But the targets keep on changing. We had set a target of 60% reduction by 2050, revised it to 80%, then to 90%, then changed the target to 2030. So things are only going to get more demanding, and we're going to have to change faster. And I have a simple question for us. What will 2050 actually feel like when we emit perhaps 100% less CO2 than we do today? My son will be my age in 2050, and I don't want to have to apologize to him tomorrow for what we could and should have done today. So our job is to make sure that our buildings use less energy. But it's not all about new build. A recent report called Fawlty Towers says that we have a huge problem in our existing building stock. And in fact, 60% of all the buildings we need in the 21st century are already built. So we have locked a problem into our existing estates, and we need to start thinking more about retrofit as well as building nice new low energy buildings. And the Fawlty Towers report goes on to say that this is a strategic risk for people who own very large portfolios of buildings, and that because of their CO2 emissions, the value of those assets will reduce faster over time than better performing buildings. And some people believe that we could have a renewable energy revolution that could see new buildings actually being net exporters of power using very large photovoltaic arrays. But I don't think that's going to happen in my lifetime. Better still, I think we need to put buildings into rehab and wean them off their energy addiction. This will deliver a net CO2 reduction. So let's look at energy a bit more closely. So we measure energy in kilowatts, but what is a kilowatt? Well, some of you might remember these. These are old-fashioned light bulbs. And if that were a 100-watt light bulb, if you could picture holding your hand above it, you could probably only hold it there for a fraction of a second because it gets very hot. And that's because 90% of the energy going in was converted to heat, not light. And that's why they were banned. So a kilowatt hour of energy is 10 old-fashioned light bulbs running for 1 hour. So let's convert a kilowatt hour of energy into human energy. So as we've said, it's 10 light bulbs running for 1 hour. So for a man to keep those all lit, he would have to cycle at 13 miles an hour for 1 hour 20 minutes without ever dropping below that speed. And then he would need to eat 1,500 calories to replace the energy he had just spent. Or 1 Big Mac, large fries, large Coke, not diet. So a kilowatt hour of energy is the same as a Big Mac meal. So how much CO2 is emitted when we use a kilowatt hour of energy? Well, it's about a kilogram. But what does a kilogram of CO2 look like? It looks like this. It's enough to fill a large space hopper with a radius of 511 millimeters. So we do this a lot with people to help them take arcane numbers like kilograms of CO2 and kilowatts of energy and turn them into units that make sense to them. Let's continue with what CO2 actually looks like. So on the right, we see the CO2 emitted by an old-fashioned 60-watt light bulb. And on the left, a modern 11-watt LED or compact fluorescent. It's quite a difference. And the issue is, the more CO2 we put into our atmosphere, the warmer it gets, the more our weather systems change, and the more over the long run we get climate change, or as we're now describing it, the climate emergency. So where is the CO2 emitted? It's not by the light bulb itself. So for every light switch we have in a building, we have 3 wires. One goes to earth, one goes to the light bulb, and at the same time we demand energy from a power station. And it's at our power stations where we burn fossil fuels, coal, gas and oil and release CO2 into the atmosphere. And it's also worth looking at our national grid. A national grid is the pride and joy of a developed economy. But when it comes to carbon emissions, it looks a little bit stupid. We produce electricity by burning fossil fuels, coal, gas and sometimes oils at power station. We use the heat to turn water into steam, and the steam is driven through a turbine. It takes about a second to go through the turbine, and then we immediately dump 62% of that heat energy into our atmosphere through the cooling towers. So for every 100 units of fossil fuel energy we use, we dump 62%. That's enough heat energy to heat for free the entire UK 1.5 times over. That looks a little bit wasteful. Then we have to take the electricity and distribute it through transmission lines, and we only lose 3.5%. But then we deliver it to buildings that tend to be badly designed, poorly insulated, we leave the lights on, so we waste about 13% in buildings. And so by the time you do the whole calculation and you switch on a light in your home, you're only seeing 22% of the original energy generated at the power station. That's very wasteful when you think about CO2 emissions. Okay, so let's look at buildings. What are the strategies we can use to reduce energy consumption in buildings? Well, it's quite simple. It rhymes. Mean, lean, and clean. Mean are passive systems. They're generally free and we should maximize those. It includes the orientation of the building, the thermal mass of the building, how we might store and regulate heat in the actual materials the building is made of. We should look at the envelope of the building or the fabric of the building and make sure it's well insulated and airtight. We can use natural ventilation in summertime to make sure our buildings stay cool. And we can maximize daylight to reduce our reliance on artificial light, and use solar gain to heat in winter, but make sure we don't overheat in summer. And we can use air tightness to make sure that the building isn't leaking in a way we have no idea about. Those are the mean systems. Then we move on to the lean systems. These tend to be active. That means we use energy. We therefore emit CO2, and we have to spend money to pay for that energy that we use. And they impact, as we've seen already, and so our job is to minimize those. And those systems are our heating, our lighting, ventilation, and cooling. And the last is clean, renewable energy to meet residual demand. And it's really important we do it in that order: mean, lean, then clean. We shouldn't use clean energy to fix buildings that are inefficient. We should fix the buildings first. And what is the regulation that makes us think harder about this? Well, some of you might recognize these energy certificates, and we're obliged under the Energy Performance in Buildings Directive to make sure that we record how our buildings perform. We can then see where they're doing well or doing badly, and then we have to change, hopefully, to improve their energy performance. And we're not the only people who have to do this. Every EU state does this, and these are example certificates from all across the EU. There are lots of them. So let's look a little bit closer at them. And here we can see that it shows us the total CO2 emissions from our heating and our electricity. So why the big difference? Why so much is allocated to heating with electricity? And if you remember that national grid story I told you earlier, here's why. So to heat a building, we tend to use gas locally, and we use 43 kilowatt hours of energy to heat this building, for example. But to light it and ventilate it, we're using 53 kilowatt hours of energy. Why the big difference in the bars? Well, the heating only emits 24 kilograms of CO2. But the electricity that we use uses 68 kilograms of CO2. And that's all down to the inefficiency of our national grid system. To produce 1 kilowatt hour of electricity in our national grid emits 2.8 times as much CO2 as heating a building using gas locally. But it's not all bad. We are slowly decarbonising our national grid, and for example, Didcot Power Station was demolished just last year. So let's look at this building over time. And here we can see 4 display energy certificates. The first one on the left, we're doing pretty good. we have 42. Then the following year we improve. We do that through energy efficiency and behavioral change, working with the building occupants. And then it gets suddenly down to a C. But we know why this happened, because we had to add some workshops in, and there was a lot of electrical equipment that went into the building at that time. And then it gets even worse. We're down to 67 and just on the edge of the C to D boundary. And why is this? Well, this is a school of architecture that has gone from 200 students in the first certificate to 750 students in the final certificate. So energy use is also linked to how many people use the building and for how long it is used. And this building is now open to students 24 hours a day. So how efficient can new build buildings get? Some of you might have heard about Passive House. It's the most rigorous energy standard available to anybody. So I'm just going to quickly describe how Passive House works. So Passive House is designed to make sure that we have continuous insulation, including below ground, and basically we want to make that consistent all the way around the building. Then we have to minimize something called thermal bridging. That's the means by which heat is conducted through materials to the outside world. So we want to minimize those thermal bridges. The next thing that Passive House deals with is something called air tightness. And buildings that aren't designed to be airtight will actually leak air through gaps, cracks and holes we don't even know exist. So if we pay attention to how airtight a building is, we can control the heat loss. But we must also ventilate very well with airtight buildings. And in Passive House, we use something called mechanical ventilation heat recovery. So what we do, as we take warm, stale air, we pass it through a heat exchanger and exchange the heat out of the old stale air and into the new fresh air coming into the building. That is mechanical ventilation heat recovery, and this reduces the heating loads significantly. The next part is to design and understand using solar energy. So in wintertime, we want to be able to collect energy to help us heat the home, but at the same time, because we've got a super insulated structure, we have to shade those windows in summer so we don't overheat. And it's always a balance between the two. But the most important thing about Passive House, it's a comfort specification, and it's not all about the numbers. The key aspect we're trying to make happen is to create a building that has no drafts, has no cold radiance through cold surfaces, will not overheat in summer, and has a continuous supply of fresh air, so that the whole house is warm and we can eliminate fuel poverty. And we do this all by simply improving the build quality. So, if you're involved in buildings in any way, we have to work with the building regulations, and they go from Part A through to Part M currently. They're detailed, they change, they get updated, and it's quite hard to keep on top of them all. But perhaps something the Ministry of Justice could think about is creating its own regulations. I've called it Part Z. And I think what this can do is create a set of standards and regulations that tell us why we need to do what we're doing: climate change, climate emergency, reducing CO2 emissions, creating better, more comfortable buildings. We can then learn how to do that, and then what we can do on a daily basis to manage and maintain those buildings to make sure that they are constantly helping us to create a better environment to live and work in, and ensuring that they're not impacting negatively on our neighbours and the planet as a whole. So thank you very much for listening to me, and I hope you enjoyed the presentation.